Hey, and welcome back to the channel. For this video, we're going to be doing big picture architecting. Now, what does that mean? Well, stay tuned as we go through Microsoft Azure Data and AI services, and we put together an architecture based on a customer example. Well, with that, I'd say let's get started. Okay, so what do I mean by big picture architecting? Well, it's understanding Microsoft's key intent for why they released the service. What's its purpose and what is it meant to do? That's how you know how to insert into the big picture. Let's try it with Azure Data Services. Well, we're going to take these 25 that you see on the page. So we can break those 25 into these categories: accept, store, enrich, engines, explore, and orchestrate. Let's start with accept. Well, we accept data a couple of ways, but one of those the two ways I see is basically event hubs and IoT hubs. Event hubs is great for sending data, not great for replying. For replying, you'll need to use IoT hubs. So that's sending data back to the device to say it's all okay. Now, if you're not sending data in via devices, you have a couple of other options. One is functions. Functions are great for standing up an API that a service can post data to. The next is storage. Yeah, you can upload data straight to storage. You've seen me do it with on-site applications when we upload photos that are taken by the user. The other part you'll see is you can set up file shares in terms of storage. So you could have a file share where a person drops it onto that share drive and then it's automatically inside Azure storage. The next part is SQL. Yes, you can land and accept data straight into SQL as well. That's perfectly viable and it's done by a lot of businesses. But let's talk about why you should use storage. So going across to storage, well, normal storage accepts any type of data, and that's why you'll be using it. You don't know what your data looks like, or you do need to share that data to other businesses quite easily. That's supported inside of Azure Files, and it's a great service to be looking at inside of storage. The other thing you'll be looking at is basically maybe storing any types of data. So we're talking MP3s, files, images, JSON files as well. You can store all of them inside of storage. Now, talking about JSON, well, talking more about NoSQL and the NoSQL side of things, that gets us to Cosmos DB. So if you've bought the on and off-shelf application and it demands MongoDB to be its backend, well, Cosmos DB supports having an endpoint of Mongo across the top of it. And that's why it's great. The other reason it's great, Cosmos is truly global. So I can have writes happening in the US, which are replicated to Australia and then replicated to Japan instantaneously. Its SLA is phenomenal and really good. And that's why I'll say look at Cosmos, but emphasis on its NoSQL. The next one we go into is Databricks. Databricks Synapse kind of similar in terms of what they do. So they both have Spark engines inside them, although I should say the Spark engine is ahead with Databricks. That's kind of expected because they wrote Spark at the end of the day. So Databricks, the question is, it's going to depend on preference. So Databricks is great if you're basically using Databricks and you've got people who are in the Spark world as well. But those Spark people could also come across to Synapse. Now Synapse puts together Microsoft's best breed of technology. So it's putting in Data Factory built into it. It's got normal T-SQL inside of it. It's got Spark inside of it as well through Jupyter Notebooks. It's all inside there. There's lots you can do inside. It doesn't have machine learning inside of it. Use another service to do that, but there's a good reason why. It's also got Power BI in there, but I suggest you build your Power BI outside. Again, whether you use Databricks or Synapse, personal preference it's going to come up to and preference of the organization. The next one is SQL. So yes, you can store your data inside SQL. Why I like storing in SQL, well, it's great for off-the-shelf applications who demand having a SQL interface. So we're talking things like adaptive insights, which need to have things like a SQL interface to go into. Now, those are the storage services. Let's go next in terms of enrichment. So what we're going to do is we're going to enrich it and then put it into storage, or maybe enrich what we have in storage. Now, it's going to depend how fast it's coming in. If it's coming in as a stream, we're going to use stream analytics. Great for analyzing things on the fly before they go to other places. If we've got lots of data which we need to analyze in batch, and think it's things like telemetry, things like stuff off devices, we'd use Data Explorer. Data Explorer is great for exploring large amounts of data and doing it based on each query you run. Now, if you want more of the notebooks approach, you'd be better to go across to Databricks or Synapse. I would say as well, I put SQL inside there because you can absolutely enrich your data inside of SQL. The next one is Analysis Services or Power BI. So think things like cubes, you're modeling, doing things like DAX, they're great for doing that. I see more customers using Power BI nowadays over Azure Analysis Services, and that's just because of the sizes being supported in Premium now. You can support very large models in terms of inside of Power BI. Let's next go across to engines. So sometimes when we enrich, having things like Spark isn't enough. We need other engines so that we can basically do smarter analytics. Machine learning allows you to take your data science models, train them, make them amazing, make them better, make them handle things like bias as well. And it allows you to stand up an API endpoint. But sometimes you don't want to build the data science, you just want to use a pre-built algorithm. So we're talking things like computer vision, things like sentiment analysis, things like receipt scanning, things like recommendation engines, lots of different things, speech recognition, identifying the speaker in the room. All of these are exposed in cognitive services, ready for you to be consumed. Not much code has to be written, especially no code for the actual data science, just for calling it. Great for developers. The next one is Maps. So Maps is Azure's mapping service. So it's great for rendering maps on applications, but in the data world, why I use it is for standardizing addresses. So remember when we have an application and all users enter in addresses and it all comes out all different? Well, you can use Azure Maps to normalize those addresses. The next one is functions. So functions allows you to write any piece of code and run any code you want. That code could be across C#, Python, Node.js. I think there's even PowerShell as well. I'm sure I'm missing one, but you've got lots of different options. If you want a long-running task as well, look at something called durable functions. So those are our engines that we can use. The next part is explore. So a couple of different places I want you to go here. Are you analyzing telemetry data? If you are, that's including website telemetry. Log analytics are great for analyzing logs. If we've got IoT devices, well, let's look at IoT Central. If we're looking at time series data, so data that comes over time, we're looking for things like anomalies over time and different trends and seasons. Well, time series insights is great for that. You don't have to write much code for your exploration. Data catalog, we use that to explore things like lineage. Where does a piece of data sit? Where does it come from? The next one, a bit cheeky putting it in here, but bot services. So exploring pieces of data, we could ask bots different questions, like what's the weather today? Where can I find this piece of data? I've even plugged in data catalog to bot services before. That's how you build chatbots inside of Azure. The last one is Power BI, of course. So we explore data inside of Power BI. That's either through reports or models that we're building. That's explore done. Then the last part is orchestrate. So we've got two options, well, three options here. One is logic apps. If your data is small, your payloads are small, and you're integrating between different services, use logic apps. If the data is big and you need to shift it from A to B, we use Data Factory, even if we need to call a service as well. If the data is small and we need to do a specific task, more a granular task, and we want complete freedom, we might use functions. Now, all of these are assisted best practice by Azure Key Vault. That's where you get your credentials. And lastly, Event Grid is great for notifying different applications because you can publish notifications and events there. And that's also where things like Azure Storage events and different Azure services log their events. Now, let's go across to our actual big picture architecting with an example. So for this, we're going to have a financial institute. They've got two requirements or two applications. One is a Google Play Store application that talks to a Mongo database and needs to get real-time answers on customers' predicted loan repayments. That sounds like a data science algorithm. The other requirement, profit and loss reporting, customer satisfaction reporting on analytic outputs that are done by a centralized data science team, well, a data science division. Okay, so interesting. So let's start with the Android application. These are the services that we're going to use for the Android application and the Power BI report. And like I said, let's start with the Android application. So what does that connect to first? Well, for the predicted loan repayments, that's a data science algorithm. That's going to be Azure Machine Learning. Because remember, its intent and its purpose was for machine learning algorithms. We saw MongoDB. NoSQL, well, going intent-wise, again, we'd use Cosmos DB, and certainly that's why it's connected. Let's then talk about Power BI. So we're getting centralized data, we're getting data that's being outputted by a data science division. They might choose to write it out to Azure storage. And that's great for Power BI to pick up for. Remember I said the differentiation is I would have put a SQL database if it was a system trying to get data out of it. The next part, let's talk about where these services get their data from. So Databricks or Synapse, whether you choose, would be great for these people because it allows their data science division to basically do that analytics on the data that's coming in. They can then output it to Cosmos DB and storage. The next part we're going to look at is where does Databricks get its data from? Well, Databricks and Synapse get their data from storage, most likely, and that's where we're going to be uploading our data from our different systems and staging our data ready for the data science division team to do their analysis. Now, when we talk about the actual other data that's coming in, we can see that there was a real time. Now, we can see that the real time is being brought in through event hubs, and that's because we don't need to talk back, we're just streaming in data. The other service we're using is Stream Analytics there. We can see there's an arrow down to Azure Storage. Well, that's because it uses reference data from there. And lastly, we had a new requirement come in, which is a way to programmatically access notifications of fraudulent transactions as they happen or unexpected behavior on one of our apps. So we could do that prediction by looking at our Stream Analytics, passing that against a scoring endpoint in real time on Azure Machine Learning, and going out to Event Grid, which you'll see out here for our notifications. So with that, that's big picture architecting. We basically looked at those different intents. Let's do a summary now. Alright, so recap time. That's big picture architecting. We looked at the intent or the purpose of each of the services, and that allowed us to put in where they should be appropriate. Now, that's what I challenge you to do. Your job is to demystify Microsoft's Azure offering. It's basically learning what each service is intended to be used for. And then on top of that, you need to know how to customize it, but that's basically for another video. Now, if you did like this video, I want you to hit the like button. I think we should do more architecture or decompiling architectures in the future, and I plan to. And that's why I would say as well, it's most important, if you haven't already, go and hit the subscribe button, as I'm going to be uploading plenty more content in the future, and I'm sure you want to be notified about it. Well, with that, I'm going to wrap up there. This is Coder Meets Data, Travis Sansom. I'm going to sign out on this one, and I'll see you in another video.